want to find the derivative of f of x in two different ways. The first is I'm going to use the quotient rule. Now, for the quotient rule, the first thing I'm going to do is I want to take the derivative of this numerator. If you're familiar with the chain rule, this would be a good place to use it. If you're not familiar with the chain rule, you're just going to have to go ahead and multiply this all out. You're going to have to take this x plus 1 and multiply it by itself 3 times. So let's just start and let's just take these first two factors. And I'm going to multiply those together. And I'm going to get x squared plus 2x plus 1. Then I'm going to take those and I'm going to multiply it by this last factor, the x plus 1. First thing I'm going to do is I'm just going to multiply this x through each of these terms, and I'm going to get x cubed plus 2x squared plus x. And then the next thing I'm going to do is I'm going to take this 1 and I'm going to multiply the 1 through to each of those terms. And I'm going to get plus x squared plus 2x plus 1. And then all that's left to do is I just need to combine like terms to simplify this. So that's going to give me x cubed, and then I see I have a couple x squareds here. I've got the 2x squared plus x squared, so I get 3x squared plus 3x plus 1. That's what my numerator is when I multiply it all through. So I'm going to go back here on this left-hand side and I'm going to rewrite the numerator in this form. So if that's my numerator, then what I need to do is I need to take the derivative of my numerator, and I'm going to rely heavily on the power rule for this. What I'm going to do is I'm going to drop down my exponent, the 3, and then I'm going to subtract 1 from that exponent, and I get 3x squared. That's the derivative of x cubed, and I'm going to keep going in that manner. And I get the derivative of my numerator. Next thing I'm going to do is I'm going to put my denominator over here on the right hand side. I'm going to take the derivative of the denominator, which is just 1, and put it here. We have a system for using the quotient rule. I'm going to take the derivative of my numerator. I'm going to multiply it by my denominator. So I have this whole quantity, the 3x squared plus 6x plus 3. I multiply that whole thing, so I put parentheses around it, times x. Next thing I'm going to do is I'm going to put a little minus sign. And then I'm going to go on to the next part, which is to take the derivative of the denominator and multiply it by my original numerator. So I just have 1 times that numerator, 3x squared, 3x plus 1. Now the whole thing is going to be over my original denominator, which was x, square it. Now all that's left to do is just to simplify this. So let's go ahead and let's multiply this x through each of these terms. So we have minus x cubed minus 3x squared minus 3x minus 1, and that's all over x squared. And then we just need to combine like terms. I have 3x cubed minus 3x cubed, so I have 2x cubed. Then let's look at the squares. Plus 6x squared minus 3x squared. I have a total of 3x squared. I have plus 3x minus 3x. Those are going to cancel out altogether. And then I have minus 1, and that's all over x squared. So you can leave it like that, or you could rewrite it. And we could take that x squared to each of those terms, and we get 2x plus 3 minus x to the negative 2. You can write it either way. Now let's go ahead and let's use the next method. Let's use the power rule. So what I'm going to do with this is I'm just going to rewrite my original function with that numerator multiplied out and expanded. And then I have my original denominator of x. So what I want to do is I want to take that denominator and I'm going to take it to each term in the numerator. So I get x squared plus 3x plus 3 plus x to the negative 1. So that's f of x just rewritten in a different form. And now it's in a form that I can use that power rule. So my derivative, or my f prime, using that power rule, and I'm going to use this form right here. I'm going to drop down that exponent of 2, subtract 1 from the exponent. Same thing here, drop down that exponent of 1 and then subtract 1 from the exponent, and I get x to the 0, which is just 1. So that derivative of 3x is just 3. Now the derivative of my next term, 3. Anytime you take the derivative of a constant, that's 0, so that went away. And then my last one, I'm going to drop down that exponent, which was a negative 1, and then I'm going to subtract 1 from that exponent. So negative 1 minus 1 is going to be negative 2. I can rewrite this and just clean it up a little. Now, if you'll notice, this is the derivative we found using that quotient rule, and here's the derivative we found using the power rule. In general, if you have a function that you can skip using the quotient rule and use the power rule, do that instead. Most of the time, it's going to be a lot easier.